Hi everyone, we are Emmi Poota
and Jussi Mikkonen.
and today we will present you our literature review on woven eTextiles in HCI. Textile materials have long been used to extend the ways people interact with physical interfaces. Over nearly 3 decades, advances in functional materials and flexible electronics have enabled new means of integrating distinct electrical properties into textile materials. This development has opened new avenues for multidisciplinary research in which such fields as electrical engineering, material science, computer science, and textile design come together. Recent years have witnessed the focus of that research move increasingly toward how functionality can be incorporated into the very structure of textiles, instead of textiles serving as a mere substrate for electrical and interactive elements attachment. This shift has resulted in increased use of textile-oriented construction methods in smart textile development, thus calling for a fuller understanding of textile materials and fabrication techniques. One of those methods gaining increasing attention is weaving. In a nutshell, weaving is a method of interlacing a minimum of 2 sets of yarns, warp and weft, to construct a fabric by a loom. The weave of the textile determines how the weft and warp are intertwined in its structure. The most simple structure, plain weave, consists of 1 set of weft and warp. Additional yarn sets can be used either as supplementary yarn, for example for decoration, or as complementary yarn to create 2-sided double-faced weaves. With complementary yarn sets, the amount of layers can be increased, like in double weave or its interconnected counterpart, double cloth. The layer count of these weaves is not limited to 2. While throughout reviews of eTextile technologies are available, summaries focused on the ways of utilizing weaving, complex woven structures especially, in eTextiles for HCI remain absent. In addition, publications have disseminated little of the textile-related knowledge, and descriptions of the woven structures and weaving techniques and so forth have often remained vague. Our objective in this review is to increase the understanding on how weaving has been used in eTextile research in the various related fields and draw conclusions for advancing eTextile research in HCI. Therefore, we applied an integrated literature review method to search for an answer to that question. The corpus of 103 records included both academic and grey literature from the HCI field and various related domains, gathered through database searches and citation tracing. To acknowledge the multidisciplinary nature of eTextile research, we approached this review from 2 perspectives, that of a textile designer and of an electronics engineer. That provided us with a lens to analyze the records, first to specify what electrical functionality can be achieved through weaving, and secondly, to understand how weaving contributed to the functionality described and which specific weaves, structures, and weaving techniques were employed.
To sum the main insights from the review, 3 core characteristics of weaving together enable construction of versatile woven eTextiles. Firstly, the orthogonal arrangement of the warp and weft yarns makes woven textiles structurally stable, providing a suitable base for eTextile construction. Second is the facility of precise control over how the weft and warp yarns intertwine within the woven structure from utilizing a jacquard loom and/or techniques such as warp and weft patterning. Thirdly, because several fiber types can contribute to the woven textile, the resulting construction may take advantage of multiple individual materials' characteristics. All those contribute to the construction of multi-material composites, which benefit from the distinct properties of various materials, allow integration of complex circuit topologies, and can also consider the visual and tactile surface characteristics of woven eTextiles. Our analysis of how electrical functionality was achieved pointed towards 3 distinct functionality categories. Some sources cross between multiple categories as they describe more than one textile, or they present textiles integrating different electrical functionalities. An electrically functional weave is an electronic component formed by combining structure and different materials during weaving in such a manner that the resulting component is an inseparable part of the textile structure. These weaves are further divided to woven sensing, woven actuators, and other functional weaves. Wovening components are integrated components that are woven into the structure but are actually not part of the textile's fundamental structure. So removing them would not cause much change to the textile itself. The third and final category is called electrical signaling. It focuses on how electrical functions can be connected or how networks are formed within the woven textile. The body of the literature reviewed presents a great diversity of various weave structures and weaving techniques used in woven eTextiles. Simple weaves were used to form a stable one-layer structure within which functional and traditional textile yarns contribute equally to the textile. Supplementary yarns, in turn, augmented simple weave structures with location-specific functionality. And double-faced weaves were used to locate different surface properties on the different sides of the same weave. Double weaves were often applied to create pocket structures of various sizes for housing of functional materials or hardware components inside a textile. Double cloth, on the other hand, seemed to provide a firmer base for sealing supplementary functional yarns or yarn-like components inside a textile thanks to its interconnected layer structure. Finally, multi-layer structures combine several double cloth and double weave structures to, for example, provide insulation and 3D volume. So, to sum up with a heat map which is based on Table 2 from page 6 in our paper, we can see what combinations between the electrical functionality and the woven structures have been most explored. The first woven structure, simple weaves, are most represented even though our literature research leaned towards complex textiles. As the name suggests, simple weaves are the simplest to create and can also be woven with most looms. On the other hand, double weave structures have seen most work with electrical interaction functionality compared to the other categories. There are 5 categories that are completely empty. When we look at the more complex structures, multi-layer weaves, there is a vast gap and potential for research from different perspectives. We would also point out that double-faced weaves have not seen much research. Whilst as one-layered structures their potential may be limited, combining this structure with multi-layer textiles provides a lot of potential for HCI within eTextiles. Next, we will look at future research possibilities.
As already mentioned, multi-layer structures have been sparsely used in woven eTextiles, although the few records indicate their potential as an avenue for constructing multi-layered circuit boards and more versatile sensor structures. Research, for example, on woven 3D textile composites could stimulate exploring the possibilities of multi-layer structures in woven eTextiles further. Secondly, the full spectrum of interaction that the various visual and tactile surface characteristics could afford have only been briefly noted. In combination with embedded functional structures that would provide an interesting bridge for establishing a design space for tactile interaction in woven eTextiles. Finally, in order to scale prototyping efforts for industrial production, the industrially produced woven systems need to behave similarly to the research prototypes, and their layout should adapt to the grading of the sewing patterns in the eTextile products. So, how to advance the research on woven eTextiles in HCI? First of all, authors should strive for more detailed reporting and make all relevant design files accessible. As eTextiles represent a relatively young field, establishing consistent documentation is especially vital for reproducibility. In addition, the disciplines intersecting in the eTextiles field contribute to the research through their distinct perspectives. To reap the most from these many angles and thereby move towards holistic woven eTextile systems, the various fields' distinct characteristics should be interwoven within interdisciplinary research processes. This could mean, for example, regarding the methods of designing and crafting textiles not merely as construction techniques, but as vital for the analysis too. In general, eTextile evaluation needs to grow more detailed, transparent, and holistic. If you have any questions, feel free to reach out. We are happy to discuss them further.